Everyone, I'm so excited to be giving this talk today. Today we're talking about deploying models on Android apps offline. So a brief intro about me. My name is Bunmi Akinremi and I'm a data scientist and an Android developer. I'm passionate about bringing more women into tech. I'm currently a computer science undergraduate at Bunmi University. I'm also a community project lead at AI Plus OU and WIS OU. I love writing tech-related articles, and recently I was featured in a book titled The Techie Chick by Ibukun Nike. So a brief intro to what I'll be talking about today. So I'll be giving a brief introduction to what model deployment is. I'll talk about a couple of free and paid tools you should definitely try out if you want to start model deployment. And I'll give some advantages and disadvantages of offline and online deployment. And I'll give factors you should consider when you want to deploy offline and when you want to deploy online. And I'll give a summary of the whole talk. So let's get right in. So you might ask, what exactly is model deployment? So in simple English, model deployment is just a method by which you move your machine learning model from your Jupyter notebook into a production environment, into a software application where it can be used. Yes, you built a very, very accurate model, some even up to like 98% accuracy, and it just sits there in your local computer, just sits there in your Jupyter notebook. So model deployment involves you taking out that super really good model and then putting it out for your friends, people to use that will actually solve problems. Your model cannot solve any problem sitting there in your Jupyter notebook. It can only solve problems when it's integrated into a production environment. So let me give a short story of my very first data science project I tried to deploy. So I worked on a fraud detection project, and in that project I was working with a data set that had features that had user details involving their transactions on a particular website. So after training the model, I had an accuracy of about 84%, and I deployed using Flask API, and it gave me a whole new insight into what this model is, what this model can be used for, because I've worked on a couple of projects before that, but it all sits in my local system, and I was curious, like, how could this be used in real life? How could this actually solve problems? So I did some research and found out about model deployment, and when I actually deployed that model, I actually understood the workflow. I understood how my model is going to get data, how it's going to predict, and how it's going to present the results, and how the results would be useful. So that, and the model was actually deployed online because that was like my very first model. And I asked myself, do I always have to use my data, do I always have to be online to use this model? Well, for this case scenario, I always have to, because because the model was quite large, so I had to keep updated, keep connected to the server for me to be able to, have access to this model. So let me talk about some free and paid tools for model deployment. I would like to start with APIs. So an API is just something that connects your model to your application. So you built an interesting model. Your model don't just come together. They have to be like an intermediaries, except you're deploying directly on the application. But sometimes, most times, you can actually use APIs. APIs are just intermediary, like connection wires between this model and this application. So a couple of popular and common APIs are Fast API, Flask, the Django REST API. These are just a few. Fast API is a modern fast web framework for building APIs with Python 3 plus 13, Python 3 plus 6 plus version, and it has its key features that first it's fast. Yes, it's fast. It's easy to use and learn, and it requires less time to debug. In just few lines of code, you can actually deploy your model in just very few lines of code. So Flask is a microweb framework built with Python. It's considered as a microweb framework because it does not require you to install particular tools and libraries. So you can just build your web app and at the same time build your API together. And also the Django REST framework. So the Django is also a Python framework, and it's having its own REST framework for creating web APIs is a wonderful toolkit for developing robust web APIs using the Django and Python. So it gives you an easy way to serialize the data and also provide it to other applications. So now, yes, okay, I built my model, deployed it using an API, but then it's just on my local host. I need to, make this available on the server so that other people can use, so it can be accessible anywhere. And that would take me to cloud hosting platforms. There are a couple of free cloud hosting platforms, you could use that could make your model available to other people, available to other applications. The first is Python Anywhere. So Python Anywhere is a cloud program that allows you to create and run Python programs in the cloud. So basically it's for Python programs. So you can write your Python programs in a web-based editor or just run a console session. I also talk about Heroku. Heroku is a cloud platform as a service, and it supports several programming languages. It's one of the first cloud platforms, and it has a free version. So it has a free version, but you're limited to about 500 MB. The maximum size you can upload at once is 500 MB. But it's still good for trying out stuff. I will also talk about localTNL. So localTNL is a tool that allows you to deploy your model on localhost. That is, okay, you deploy the model using an API. So localTNL allows that model, that API that you deployed on your local system to be available to anywhere in the world. It just exposes the endpoint, like exposes the API to the internet. That is, yes, you deployed it using your local host, but then anyone, anywhere can also access it in just one line of code. And it's not advisable for production environments because you are exposing your API, your model, because anyone can use it. It's vulnerable to anyone, really. I would also talk about some special tools. Forest Flow is a scalable policy-based cloud-native machine learning model server. And what Forest Flow aims is that it aims to provide data scientists with a simple means to deploy machine learning models to production system with minimal issues, so you don't have to worry about issues in accelerating development to production in value proposition. I would also talk about the PyTouch So TouchServe is just a flexible and easy to use tool for serving PyTouch models. It has some really cool features like Matrix API and login that you should definitely try out. I also talk about Mia. So Mia is a platform that allows you to deploy your machine learning models and also build a simple ML app for it. So all you need to do is upload your machine learning model, then build your interface with it. So it allows you to upload your model, and you can also build your web interface together, even on the same platform. Then let me also talk about some paid hosting platforms. These are just a few. There are a lot more, and these are all MLOps platforms. So MLOps is not just about model deployment. You just talk about model, monitor your model, monitor the performance, automating the development pipeline, so you don't have to manually, improve and all that. So it also automates your development pipeline and also helps with the software integration part, that is the ML operations, your CI/CD, your and your metadata store and those kind of things. So let me talk about AWS. So AWS, which is Amazon Web Services, it allows you to upload your trained models, configure your pipeline orchestration, and also monitor the model's pipeline operation. So you can actually do so many things together. So you're monitoring the model, you monitor its performance, you're also automating, pipeline operations, that is from data preparation down to model deployment. You're updating it and you're also checking, allows you to monitor your model's performance. And it has two key benefits. The first is that it allows you to leverage a pre-configured machine learning pipeline. That is, you can use a pre-configured machine learning pipeline, and it also allows you to automatically deploy a trained model and inference endpoints. So you can bring your model, your own trained model, and it deploys it automatically for you and create an inference endpoint. So now that I've talked about all these tools, let's see some advantages and disadvantages of deploying online. That is, yes, deploying online could be really, really good, could be really convenient, but let's see some advantages and also disadvantages. So the first is that it's very simple and easy to use. You don't need to have the background, like any kind of background in machine learning, because some platforms make it just like drag and drop. So you just pick, drag and drop kind of stuff. And you don't have to deal with all the ethics that comes with your training model, improving model performance, scaling, and all the kind of stuff. It's very easy, very, very easy to scale up. That is, you don't have to, be burdening yourself about scaling. And because when your platform begins to grow, when you begin to have more users, there is always a need to scale up, and that need it won't be as difficult as if you're not deploying on cloud. So you also have access to high computing power. Depends on the kind of model it is, because some models require high computing performance power for high performance. So you have access to GPUs, CPUs, and even large storage space. So let's talk about some disadvantages. The first is that you need to pay for the service. You definitely need to pay for hosting, you need to pay for storage space, and you're also restricted to supported data types. So the platform supports images, text, and videos alone, and then you want to build a project that uses audio, an audio-based data type. So you're not able to use that platform. So you are only restricted to what they support, what they allow, and your application cannot work if you don't have internet access. So there is that barrier of internet access, and this depends on who your users are, who is using your mobile app. So that should be the consideration. So let me give an example. If you're building a solution for farmers where there is no internet access, where internet access is very bad, so you don't expect to use a cloud solution, you don't expect to deploy online, because they will not be able to access it. It needs to be inaccessible for them because there is obviously no internet access. Another issue could be that you don't have a direct access to your model. Especially on platforms where you build the model on that platform, everything you did was just on that platform. You will not have direct access, to your model. That is, you're not able to go there and just dig out your model and use it in other applications too, that may not be allowed. Okay, so let's talk about deploying offline. So what are the advantages and what are its disadvantages? The first advantage is that you don't have to pay for it. It's very flexible. You are open and you can use any kind of training software or training data that you want. You have complete control over your data. You don't have to pay for renting a cloud computer or cloud storage. You can choose what method you want to use. Deploying offline, maybe in later scenarios, you might need to deploy online and you have the flexibility of choosing, which, or you can even use both depending on your use case, depending on what you want to use it for. But it also has its own disadvantages too. And let's talk about that. The first is that you need to have confidence. You need to know what you want to build. You need to know how you want to build it, because you cannot say, oh, I want to build an image classification app and then I don't know how to go about it, and you just know. You need to know how. You need to define your threshold. You need to define your accuracy. Okay, at what point can I see my model is performing really well? At what point do I need to improve? What are the red flags I need to see? I need to check. You need to know all that. You also need to have a high performance computer, because depending on what you're building, depending on what you're working on, some could train on really, really large data, up to 50 gigabytes of data, and you need to have a high performance computer to actually handle this kind of data. And except you're going to be training online, that is, you're going to be using a particular platform, cloud platform, for training online, for training model online, you also have to pay for software and electricity bill. So why should this be an issue? Okay, assuming you're building a model that is training on like 50 gigabytes of data, it's not going to train in 8 hours. It's not going to train in one day. It could take 2 days, 3 days, and so on, that amount of time. And you have to keep paying for um the electricity bills. And also, depending on the software you're using, some some might require that you use a paid software and you have to pay for that too. So when do you deploy online, or when should you deploy offline? You need to ask yourself a couple of questions. First is that, do you have the domain knowledge? Do you have the knowledge? Do you know what you want to build? How accurate should it be? What's the size of the data set you need? Should it require network connectivity? What kind of model do you need? Do you need to make inference on the device, or you can make inference through sending requests? You need to ask yourself those kind of questions. And here are some factors to consider. The first is the size. So what is the size of a model? What is the size of what you're building? So let me give this scenario. Assuming you build a model that has the size of about 250 MB, 250 MB, and you want to deploy it on an app, and that app is about 52 MB. Okay, so after imagine having a model of 250 MB on an app of 50 MB. You can imagine the size over like 300 MB and all. And that is really large. Some models are actually larger than that, depending on the data set you trained it with, depending on how large the data set is. So sometimes models could be really large, and it's way not advisable to deploy offline, because I would not personally want to download an app of very, very, very large MB, very large. And another reason could be the speed. Okay, so if I'm deploying online, I have delays while sending requests. So the moment between my model sends request to the server and then the server gives me back, my answer is, there's actually a delay, and that delay can varies. It varies due to network connectivity. So if network is bad or is a little poor, it would actually increase that delay. And on the other side, the speed could also be in the aspect if you deploy offline, you need to consider a couple of things too. Your model should not be so large that when training on when it's making predictions on your phone's RAM, it should not um it should not take up the whole space. So you don't want to leave your user's phone hanging just because of you want to classify if something is a dog or a cat. You should not leave your user's phone hanging. That's a major, a factor you should consider. Another factor you should consider is the cost. So sometimes you have to think about it. So if your budget allows you to post online, that is, sometimes platforms allow you to pay maybe by 1,000 requests, or depending on the platform really. You have to consider, okay, depending on your user base, depending on your budget, you have to see if you can handle the cost. Or if you actually deploy offline, you don't have to pay for requests, you don't have to pay for the number of times the user makes predictions. You don't have to pay for that because it's in the app, and the user can access it anytime without you actually paying for it. Another issue could be privacy, your data privacy. Okay, sometimes when you deploy online, you are faced with the risk of protecting your users' data, your users' information. You have to find, come up with ways in which your users' data is actually protected. And if you deploy offline, you don't have to worry about losing your users' data because your users' data is stored safe in the app. The only thing you are faced with is that your model, because your model is exposed to other app developers, they can just go and then scam through and then steal your model. That's another issue you're faced with. So you're either faced with protecting your users' data or risk of losing your model. Another thing could be that if you actually upgrade, because you have to keep improving the model gets stable over time. If you actually improve this model, you have to the user have to keep downloading and update every single time. Downloading and update every single time. But if you actually deploy the model online, you don't have to. The user may not even know that this model has been improved because that is all done automatically. So the user just keeps using the app without even without being required to install any update. Another issue could be convenience. So depending on you, which method is more convenient for you. Okay, will deploying online save you stress? It saves stress. It's fast, privacy. And all the kind of stuff. You have to consider what method is convenient for you. And each of these services, they have their own trade-off. So no one is perfectly good. Another issue could be performance. So if you're if you're training, if you're deploying online, you don't really have to bother about your your model's performance. But if you're actually training your model's performance on the user's phone, but if you're training offline, like if you're deploying offline, you have to think about the user's RAM. You have to think about the CPU limitations. You cannot just use a model that will just make users users phone to just hang. You have to consider these things. And also when training your model, you have to consider, do you have the RAM specifications, do you have the CPU specifications, the GPU support, and all these kind of things. So let me give some scenarios where models are deployed offline and online. So the first example I gave is a plant disease detection app. So last year, my data science community, we presented a project at Data Science Nigeria's 2020 bootcamp, and the project is called Plant Gnosis. So it's a plant disease detection app That is, all you need to do is just take your mobile app, your mobile phone, take a picture of that plant disease, and it actually classifies and tells you what kind of disease it is. And it doesn't just stop there, it actually gives you recommendations on, you know, on what you can do. If the model is not so sure, it tells you to, it refers you to an expert. And if it's sure, it tells you, oh, this is what you can do, this is what you can do, gives you suggestions. Another scenario could be plant classification app. So if you have like a flower classification app, you know that it's actually working on a machine learning model as the back end, which classifies what kind of flower this is. And another thing could be Snapchat filters. So you have those filters that would exactly match your face, and give you all sort of funny, interesting filters. They work on machine learning as the background. Another could be Portrait Maker. So Portrait Maker is an app that takes your picture and gives you a portrait, a painted portrait. So it has been trained on, the model has been trained on, you know, a large amount of data, like couple of data, for it to be able to perfectly give you a portrait, a good portrait, irrespective of your color, your skin type, your face type, your hairstyle. It's able to actually craft out that painting of him, and it's the model would be large. So you most likely, if you're building something like that, you might want to consider deploying online, depending on where you actually want to make your inference. So you might want to make your, what if you're building something that needs real-time, classification. So maybe you want to build something that all you need to do is just to point your camera at it, and then it classifies that kind of stuff. So if you're building something like that, you know that you need to make the inference locally. You need to make it on the app. So something like that, you will need to deploy offline. You actually need to deploy offline. Another scenario could be recommendation engines. So recommendation engines are those things that work on websites that tells you, oh, customers also view this, what about this? Do you like this? Giving you suggestions on items, on products you can buy. That those are recommendation engines. And the last example I gave is chatbot assistants. So these are really common on websites, today, on apps where they assist you with whatever issues you have. So if you have questions, you have issues, all you need to do is just to, type in your questions, and then if need be, they can refer you to, a customer service agent, and all. So here is just a logo of the apps, of some of the apps I mentioned. So you can check them out. You can actually try them out. It can actually give you inspiration on how you want to deploy your model. So let me give a summary of all I've talked about. So I talked about what model deployment is. Simply you just taking your model out of your Jupyter notebook or whatever development environment you use, and putting it in a production ready environment, putting it in a software application, something that people can use, because no one really cares about your code. Okay, what can you do? What can you do? How can I use it? How can it solve my problem? How can you solve the problem? Maybe problems at home, problems in school, problems in the environment, little even problems for yourself using machine learning models. You would obviously not go to your notebook every time to be making predictions. You need something that everyone can use, that can actually bring solutions. I also talked about a couple of free and paid tools you could use. Talked about Fast API, talked about Flask, talked about the Django REST API. I talked about Python Anywhere. A couple of cloud hosting platforms like Heroku. I also talked about some paid tools you should use like AWS, Google AI platform, and a couple of others. Then I gave some advantages and disadvantages of deploying online and offline. Everyone has his own trade-off. If you decide to deploy online, you actually have the risk of exposing your users' data, because you have to be really careful, because you have to protect their data. Then you have to pay for requests, you have to pay for storage, you have to pay for computing power, you have to pay for a couple of things. And if you're deploying offline, you have to make sure you have a high in computing system, a computer with high performance system. If you're going to be training offline, then you also have to, you know, consider the phone's storage, CPU, the RAM, because you also have to consider the size. You cannot just deploy, just carry a model of about 300 MB or even more, because the models are way large, and then just dump it in another app and expect people to use it. Except you have ways in which you can shrink and compress the model. I also talked about factors you should consider when deploying offline. Consider the size, consider the performance, consider privacy, consider the costs, consider the speed, and a couple of others. Um, I and lastly, I gave you some examples of apps that use machine learning as the background, and I hope that I've been able to interest you, spur your interest, give you brilliant ideas on what you could do to those models sitting in your notebook. So just go get them out of your notebook, get them out of your local system, put them out there, use them to solve solutions, solve problems, bring solutions, don't just build models and then let them just die there in Untitled 1, Untitled 2, Untitled 3, Untitled 20, notebooks, actually bring them out and make them useful, to solve problems around you. And if you're thinking of problems, you don't have to think big. You don't have to think of something that is so big. You could just start where you are, your room, your family, something that could unite you together, something that could make you guys have fun. It could be something that could solve electricity issue, like water issue, flood, whatsoever that is actually affecting you or your community or your classmates, your friends, your peers, even in your work environment. Just you could build a machine learning model that can help that. Yeah, and also build build models for things models can solve. So there's some things that just a software application can solve. You don't need a machine learning model for that. So you need to only use a machine learning model for what a machine learning model can actually solve. Yeah. Uh thank you so much for listening. Thank you for your time. Thank you for your patience. I hope I've been able to, spur your interest. You can contact me on Twitter. My Twitter handle is @Bunmi Rose. You can contact me on LinkedIn. I'm Bunmi Akinremi, and here is my Gmail, just in case you want to send me an email. Thank you so much.